Alright, Chapter 4, Aircraft Fueling Activities. Unified Facility Criteria, UFC 346003, November 10, 2017. Petroleum Fuel System Maintenance, approved for public release distribution unlimited. Alright. Closing in. Forewarned General. This chapter contains a brief operational description of each type of the hydrogen system. Major components include each system. Hydrogen systems are site-specific. The settings provided with the manual are derived from standard designs may vary for the due configuration, climate, location of installed system. Before system components are calibrated, maintained personnel should consult as-built or startup data. Most familiar with the proper settings of specific systems. 4.2. Hydrogen system type 1. Type 1 hydrogen system is known as the Panero system. Panero system were built in the 1940s and 50s. Were first hydrogen systems used in the Department of Defense. Panero systems have been superseded with the more modern hydrogen systems, but limited number are still in use. Panero system pump petroleum fuel in refueling outlets and aircraft is moved to the outlets conducting refueling operations. These systems typically are vertical turbine pumps, and underground horizontal storage tanks. Original Panero systems are automatic control valves issued to fuel line, then filter meter pits. Major modification: original Panero created with the modified Panero system. The modified Panero system uses an automatic control valve to perform both issues and defuel operation. The U.S. uses MH2 hose cart instead of a filter meter pits, and with these systems, defuel operations are conducted with a gravity dedicated defuel tank. This shows the modified type hydrant system. Alright, 4.3, hydrogen system type 2, general description. The type 2 hydrogen system known as the Pritchard system. Pritchard system were developed in 1955 to improve the hydrogen refueling operation characteristics. These systems employ lateral control pits, typically vertical turbine pumps, underground horizontal storage tanks. Pritchard systems can serve multiple hydrant outlets per lateral control pits. The system allows flexibility hydrant outlet locations to enable the aircraft to be notified at parking positions. Type 2 Pritchard pump houses is similar to Type 1, but Type 2 Pritchard pump houses does not include a separate defuel tank. Instead, one of the system's operation tanks is designated with a defuel tank on a rotational basis. The lateral control pits include a defueling pump automatic valve. The MH2 hose cart equipped with a filter separator meter hose is used with the connection with the hydrant outlets aircraft. As a result, the filterization meters are not required for the lateral control pits. The following is simplified description of operation. Fuel issue. When the fuel is required with the hydrant operated with the operator plate for the magnet refuel magnet control assembly with the cup of the pre-selected pump with the pump house to start energize a solenoid on the refueling control valve of the lateral control pit. If the supply of the activated hydrant outlet of the fuel pump moves the pump house in the fuel manifold with the liquid lateral control pit. Fuel enters the refueling control valve, causes it to open the refueling control valve with the pressure, provides pressure reduction, non-surge pressure relief, excessive flow shutoff, and emergency shutoff capabilities. Fuel flows through the hydrant outlet adapter to the MH2 hose cart into the aircraft during the fuel issue operation. Defueling fuel valve solenoid is de-energized, but the defuel is held close. Pressure relief relieves the excessive pressure field from the upstream side of the refueling control valve. The defuel line is required. Defueling. When defueling operation is required, the operator places the magnet of the defueling magnet control assembly switch. This is coupled with the solenoid defueling valve connected with the hydrant pit to the energized associated defuel pump to start. When the defuel solenoid energizes, the defuel valve opens and fuel is drawn from the defuel pump forced through the rate of control valve with the defuel line rate with 200 gallons per minute, or 12.5 liters per second. Fuel flows through the operating tank designated with the receiver of the defuel product. Shows the pressure to Type 2 hydrogen system. 432. System-specific control valves. General system control valves. Petroleum fuel system control valves. Hydrant pressure with the upstream side of the petroleum side. Petroleum fuel piping connected with the valve to open and close the valve. The valves are equipped with flexible diaphragm control pits, but they usually operate the pilot. Control pilots usually operate the valve. The valves can be used to perform many functions. Functionality of the valve depends on the type of the control pit with the install of the valve, the orientation flow through the valve. Inspection maintenance general system control valve. Verifying operating with the setting of the valve with the valve adjustment must be in accordance with the manufacturer operation maintenance manual of the final startup of the commission set points. Used for the Department of Defense standard set points should only be used for the reference start and point of the pipe side with the other hydraulic factors influencing final system settings, frequency coordinate, remove the controller, remove the clean strainer, install the petroleum fuel line supply line, pilot main valve, the diaphragm of the strainer is provided with the prevent clogging of the orifice of the supply line. Clogging of the screen will cause malfunction of the valve. Frequency annually with the unfiltered systems as required in filtered system. The diaphragms must be removed. Inspected deterioration breaks of the flexing joint. The damage is often caused by pipe scale, pipe tape threaded, sealant compound collected above the diaphragm become lodged between the diaphragm bonnet, the bonnet of the valve, the damage of the also may over the charge of the operational petroleum fuel type of the grade, such as changing from JP4 to GP8 frequencies every 10 years. High level shutoff valve. For more information, operation maintenance of the high level shutoff valve, the HLSO valve section 896 high level shutoff valves shows the high level shutoff valve type 2 ejector with a pilot valve with a float assembly, pilot valve opening. Non-surge check valves type 2 systems. Non-surge check valves are similar to design and operation type 3. Non-surge check valves refer to section 4421. Non-surge check valves for information inspection maintenance of the non-surge check valve. It shows the non-surge check valve, your CV flow control valve, check valve, VPI, outlet, main valve, inlet, and outlet. Filter separated control valves, type 2 system filter separated control valves are similar to design and operational with type 2 3. Filter separated control valves refer to 4422. Filter separated control valve information on the inspection maintenance of filter separated control valves. Show the filter separated control valve, remote control line, three-way line, low high pressure, ABC, VPI, differential control outlet, main valve, inlet, and orifice plate. Refuel control valve diaphragm actuated refuel control valve pumps provides 5 function pressure reduction, non-surge pressure relief, excessive flow, shut-off, emergency shut-off of type 2 systems. Shows the refueling of the control valve type 2. Inspection, maintenance, refuel, and control valve. Verify if the refuel and control valve is set to maintain 100 psi gauge. Typical operating pressure measure the furthest hydrant outlet. Frequency coil relief. Verify the pressure reducing control of the 5 psi gauge above normal outlet pressure with this measure of the farthest hydrant outlet. Frequency quarter. Verify refueling control valve operating rating setting at the 15 to 20 seconds. The valve should open as quickly as possible when tripping the pressure. Differential control shut off quarterly. Verify operating excessive flow shut off function quarterly. Verify operation solenoid frequency quarterly. Refer to section 4321 for the general system control valve for additional inspection maintenance requirements. 4326 pressure relief valve. The pressure relief valve is installed with the lateral control point between the fuel issue lines and the defueling line. Pressure relief valves provide with the relieve excessive pressure caused by the closing of the downstream valve of the thermal expansion closed section pipeline. Valve is designed for petroleum fuel to flow under the seat disc inside with this valve with the fail safe the open position main valve diaphragm fails. Show the CRL pressure relief valve the strainer orifice inlet side with the refueling manifold and 90 AFA inlet with the outside the defueling line. 43261 inspection maintenance pressure relief valve. Verify the pressure relief valve within 10 psi gauge above the normal inlet pressure to the refuel control valve frequency semi-annually. Refer to section 4321 general system control valve for additional inspection maintenance requirements. 4327 the defueling control valve. The defueling control valve, the diaphragm actuated solenoid shutoff valve and defueling pump are energized simultaneously. The solenoid valve of the defueling control valve is energized with the valve of the defueling control valve to open and aid permit defueling through the system. Defuel ejector de-energized or closed 2-port solenoid inlet side T hydrant only outside inlet defuel pump. 43271 inspection maintenance defuel control valve. The defuel control valve opens when the solenoid of the defuel control valve is energized frequency quarterly. For section 4321 general system control valve for additional inspection maintenance and requirements. 4328 defuel flow control valve. The defuel flow rope control valve of the combination rate flow control valve fast. If the design hydraulically operated check valve closes the main valve against the reverse flow and performs the 2 distinct functions maintaining a preset flow rate typically set at 200 gallons per minute with it acting as a check valve to prevent reverse flow. Shows the ejector hydraulic check valve closed inlet side outlet defuel pump flow clean strainer orifice plate outside line defuel line flapper type check valve differential control 200 gallons per minute. 43281 inspection maintenance defuel flow control valve. The verified dual rate flow control valve set to maintain a flow rate of 200 gallons per minute. Verify the operation check valve feature quarterly. Refer to the section 4321 general system control valve additional inspection maintenance requirements. 433 type 2 modified control valves rapid flow modification was done with the sum of the type 2 systems to increase the 2 fuel rates to 200-300 gallons a pump of the aircraft with the transfer of petroleum fuel from the aircraft to the lateral control pit into the designated fuel tank with the defueling of the lateral in the lateral control pit. It is only used for the evacuate the house car for the aircraft with the pump de-energized. 2 modified control valves are used for the rapid flow system combination defuel flow rate with the control valve, solenoid valve, dual pressure relief with the solenoid shutoff and check valve. 433 combination dual rate of flow with the control solenoid valve with the combination dual rate flow with the control solenoid valve with the operator like with the standard dual rate flow control valve with the addition solenoid remote control operations. All settings and the functions are the same with the standard dual rate flow of the control valve. It's a combination dual flow control valve solenoid type 2. Differential control open solenoid closed flapper type of the check valve. The ejector hydro control valve. On the side defuel pump outlet flow constrainer closed. Core for display outside line side defueling line closed. 43311 inspection maintenance combination dual rate flow of the control solenoid valve of the verify the valve to maintain flow of the rate of 300 gallons per minute. Quarterly verify the operation check valve with the feature frequency quarterly verify solenoid operation quarterly with the refer to section 4321 general system control valve for additional inspection maintenance requirements. Alright, 43332. Dual pressure relief with the solenoid shut off check valve with the dual pressure relief with the solenoid shut off with the check valve itself with the modified with the hydro lateral control pit downstream with the refueling control valve between the issue with the defuel line and the relief valve with the perform the 2-function relief of the excessive pressure in the issue with the valve with the quick closing valve during the refueling operation maintained with the minimum pressure under 5 psi gauge on the issue line with the piping the refueling the pump for the operation of the valve is also flow control flow slowly control closing of the valve during rapid defueling operation. Shove the dual pressure relief solenoid shut off check valve with the type 2 3-part port solenoid close with the DHP with the ejector hydro colors auxiliary hydro low CRL high pressure CRL swing check valve CV control valve inlet hydrant outlet vent T closed outlet defuel line after defuel pumping. Inspection maintenance dual pressure relief solenoid shut off and check valve there high pressure relief of the control valve with the 5 psi gauge above refuel control valve. Pressure relief control set point at typically 110 psi gauge frequency quarterly. The very low pressure relief control valve with a 5 psi gauge when refueling the pumps are stopped quarterly. Verify the closing speed with the provide with the smooth pulsation free operation quarterly. Verify the operation solenoid valve with the frequency quarterly. Refer to section 4321 general system control valve for additional inspection, high maintenance, and type of the requirements. Hydrant system type 3 general description. The Department of Defense large frame aircraft with direct fueling system is referred to with the type of the 3 of the pressurized fuel systems. If the system is generally compromised with the 2 operating storage tank of the pump house, the hydrant loop of the hydrant outlets for the aircraft parking and the operation for the 2 redundant program logic controllers are used for the control of the operation of the system, include with the pump of the control valve of the system is constantly pressurized with the operation of the petroleum fuel is pumped from the tank through the filter separated and issued with the venturi with the hydrant loop of the petroleum fuel for the appropriate hydrant valve with the hydrant servicing vehicle with the mobile pantograph into the aircraft with the back pressure control valve keeps hydrant loop with the preset pressure for the relief and return venturi with it becomes measure for the flow back with the storage tank with the where in conjunction return the venturi pumps are turned on and off depending on the petroleum fuel issue. Requirement systems are generally each system size is 600 gallons increments of the 2,400 gallons per minute with the issue pump at the side with the provide with a minimum of 100 psi gauge and furthest hydrant outlet with the hydrant with the pit control valve with the clip with the pressure control valve surge shutdown pit with the newer system also include the differential pilot. The pilot controls are set at 45 psi gauge and 50 psi gauge respectively. Hydrant control valves allow the rate flow rates of the 900 gallons per minute. Using 4-inch valve bodies with the hydrant control valves are typically set with a 600 gallons with a flow rate of 1,200 gallons per minute with it possible within 6-inch hydrant control valve bodies. Type 3 shows the hydrant valve hydrant system and 442 system specific control valve non-surge check valve the diaphragm non-surge check valve not meet for the requirements of unified guideline specs 3352 4314 aviation fuel control valve the the flow for the control feature for the discharge pump non-surge check valve the to prevent the pump of the running out of the curve of the petroleum fuel flowing with the multiple filters separated to prevent the backup of the flow through the flow. Non-surge check valve shift the flow control valve check valve VPI outlet with the main valve with the inlet valve with the inspection mate with the non-surge check valve. For more information on features valve setting with the replacement, refer to the commissioning documentation as built with the manufacturer operation manual with the manual verify with the main valve value of the opening speed with the typically 20 seconds adjusted requirement semi-annually. Rear valve value maintain 650 gallons within flow rate with adjusted as required semi-annually. Ensure that the check valve is operating properly with the frequency with the semi-annually. Refer section 4321 general system control valve with additional inspection maintenance requirements. Filter separated control valve. Filter separator control valves that meet the requirements of the unified facility leak guideline specs of 33, 52, 43, 14 aviation fuel control valves used for the control of the rate of flow through the filter of the separated reverse flow, prevent the valve or addition of the water level of the flow of the control reach for the highest position accident of the emergency shuttle valve when equipped with the emergency stop solenoid valve. The filter separated control valves operate with 600, 900, or 1200 gallons per minute based on the rated flow capacity of the filter separated control valve, the low high pressure check valve of the rejector, CDHS2B control valve, CV control, flow control, VBI check valve outlet, flow clean strainer, orifice plate. Inspection maintenance of the filter, separate control valve, the filter, separate control valve, emergency shut off the solenoid under the flowing conditions, ensure the valve closed within 10 seconds with the EFSO, with the button activation, coordinated with the over EFC FSO listed in 9121, inspection maintenance electrical equipment frequency quarterly. B operated test button with the install with the ensure the filter separator control valve with the high water level of the pressure. Physically pressure with the test button, recirculating fluid, ensure with the fuel separator control valve closed with no closing speed with the function with the number of the open filters separated, the number of the pumps operating with all the filters opening and only with the one pump operating. The valve will close very slowly. Verify the valve maintains flow rate with a typically 600 gallons operating range for the base of the commission documentation. Just the flow rate is required for the flow rate to determine the filter separator vessel gallons per minute rating or element flow with whichever the life of the return of venture is measured the conform flow rate during the valve testing and adjustment and frequency necessary. Frequency annually. Or to ensure the check valve of the function operating properly with frequency annually. E to buoyancy for the water level flow. Remove the ball of the flow with assembly placed within the bucket of the water correctly operating on the ball of the flow at the top of the water. Serve the frequency of the calls your cartridges are charged. Refer to section 4321 general system control valve for the additional inspection maintenance requirements. 4423, the U-fuel flush valve. The U-fuel flush valve is meet with the requirements of the Unified Facility Guidelines 33, 52, 43, 14 aviation fuel control valve. The control of the two different solenoids. Solenoid A, control of the D-fuel portion of the main valve. The holes of the valve close any type of the fuel pump with the running. Solenoid B, control of the flush portion of the main valve of the functions only when the system is placed in flush mode. With the leave of the pump of the de-energized with the solenoid of the A, the energized allowing the valve to open and drop of the system pressure with the 80 psi gauge while the system is idle position with the valve is open with the allow the defueling with the hydrant loop of the pressure rises above 80 psi gauge. Defueling can be conducted with the hydrant hose truck for the tip to the pump fuel aircraft with the fuel with the hydrant loop of the hydrant hose truck will overcome the 80 psi gauge of the setting of the defuel flush valve opening of the valve of the solenoid beat energy of the system in place for the flush mode. Flush mode is used to move the fuel from the system in order to clean the loop. The flushing procedure for the very base of the system design of the should be approved and military for the specific SME. The D-fuel flush type 3, solenoid B, solenoid A, CRL A, 5A control, hydrol, restriction check valve with the hydrol, with the CV flow control, check valve, CV control, open, inlet flow, clean strainer, outlet, inspection maintenance of the D-fuel flush valve with more information features with the replacement with the refer to the commission documents as built with the manufacturer operation maintenance, the manual with the ensure with the solenoid A and B, or de-energize the system automatic mode, lead pump operating the frequency quarterly, ensure the solenoid A is de-energized, is energized and solenoid B to de-energize, allow the main valve with the valve open with the drop of the system pressure with the 80 psi gauge. When the system is automatic mode, lead to pump off of the frequency quarterly. See the ensure the solenoid A to de-energize the solenoid B to energize the system and the is in flush mode quarterly. Ensure solenoid A and B to de-energize the system and the tightness of the test for the mode frequency quarterly. Check opening and closing speed. The speed should be set as far as possible while still maintaining a smooth operation frequency quarterly. Refer to section 4321 general system control for the additional inspection maintenance for the requirements. Issue ventry downstream of the issue with the filter separated manifold, typically with a rate of 2,400 gallons per minute. With the ventry with the upstream and the downstream sensing line connection to the redundant differential pressure transmitter to the control of the PLC determines the flow rate of the electrical signal of the differential pressure transmitter. Show the issue ventry with the inspection maintenance. The issue ventry entry with the differential pressure transmitter reading the same value with the plus or minus 2% full scale with the frequency semi annually. Refer to section 674 with the differential pressure transmitter for the inspection maintenance required with the differential pressure transmitter. Return ventry located with the upstream with a back pressure control valve that is in similar to the issue ventry with typically 800 gallons per minute. Issue inspection maintenance of the return ventry. The ensure the differential pressure transmitter with the reading of the same value with the plus or minus 2% full scale frequency semi-annually. For the 674 with the differential pressure transmitter with the inspection maintenance requirement of the differential pressure transmitter. Your back pressure pressure control valve. Back pressure control valves to meet the requirement of the unified guidelines spec for the 32, 52, 43, 14 aviation fuel control valve used to maintain the constant hydrant loop pressure with a value of typically 6 inches, and the valve with typically set with a maintain 100 gauge PSI fuel pressure with a further hydrant outlet. Solenoid CRL pressure relief valve, check valve, VPI, and inlet with the flow cleaner, strainer, CVL control, closing, VBL control, opening, check valve with the restriction center, hydral. Inspection, maintenance of the back pressure control valve with more information. Feature for the valve, stating with the replacement referred with the commission documents as well with the manufacturer operating maintenance manual. Verifying constant upstream with the pressure for the maintain with the set point established listed in the system commissioning documents adjusted over the back pressure control valve with its necessary frequency quarterly with the energy sure solenoid A is energized with the solenoid B to de-energized while leaving the pump with the operating automatic mode. Quarterly C and solenoid A and B with the de-energized prior to the pump lead pump and shutdown system going in standby frequency quarterly. Ensure the solenoid A and B to de-energize the system in flush mode frequency quarterly. Ensure solenoid A and D is de-energized, solenoid B is energized while the system is tightness test mode. Verify closing speed control valve that should be closed as fast as possible with maintaining smoothing operation. Check for the solenoid EFSO feature with the equipment and coordinate with the test of the overall EFSO tested with the section 9121 inspection electrical equipment frequency quarterly for section 4421 general system control valve additional inspection maintenance requirements. Alright, 4427 for the pressure control valve. The pressure control valve is required with the unified guideline spec for the 33, 52, 43, 14 aviation fuel control valve. Reduce the system pressure for the 75 psi gauge during the system shutdown process to provide the thermal relief during idle pressure. Valves are typically 2 inches of the solenoid installed with the verify valves and energize with the close of the valve with the lead pump. The operating the de-energize with the lead pump stops. When the solenoid is de-energized, the valve opening with the due for the system pressure 75 psi gauge. The thermal relief function is operable. The pressure release of the 75 psi gauge valve opens with excessive pressure flows to the operating the storage tank with the valve opening the closed speed control typically set for 3 seconds into some of the case to prevent valves shattering. The pressure control valve with the pressure sensing line is connected to the large D fuel flush line. So the pressure control valve type 3, the CRL pressure relief valve, the solenoid hydro check valve, VPI inlet with the flow cleaner of the CVL control valve closing, CV control valve opening, check valve restriction assembly. Inspection maintenance with the pressure control valve. For more information, features of the valve saying with the replacement referred to the commission documents as built with the manufacturer operation maintenance manual with the energized solenoid A and solenoid B. De-energized while the system is automatic mode with the lead pump is operating frequency quarterly. Energized solenoid A and B with the de-energized the system in automatically mode with the lead pump off the verify the valve with the maintained system pressure 7 psi gauge. Ensure solenoid A is energized with solenoid B is de-energized while the system is in flush mode. Lead pump is operating frequency quarterly. Ensure solenoid A and B is de-energized while the system is in flush mode and the pumps are off frequency quarterly. Ensure solenoids A and B energize with the system in the tightness test with the mode frequency quarterly. Verify the closing speed with the control to show the close the fastest if possible with still maintain the smoothing operation frequency quarterly. Refer to section 4321 general control valve with additional inspection maintenance requirements. The hydrant control valve. The hydrant control valve meets the requirements of unified with guidelines spec 33, 52, 43, 14 aviation fuel control valve provide with a constant level of the pressure with the relief of the excessive pressure and an air sensing line with the connected with the H hydrant hose truck with a hydrant control valve with a 3-way hydraulic operated with a diaphragm actuated glow valve with a hydrant hose truck. Pneumatic dead man is in depressed air with the supply with a 3-way valve with allowing the valve to open the fuel as sensing line with the connect with the hydrant hose truck. Venture with the pressure reduction control or CRA pressure control relief control CRL on the hydrant control valve of the venturi is calibrated to provide the same pressure for the actual nozzle pressure for the skin aircraft of the pressure reducing control. Maintains 45 psi with the nozzle with the hydrant control control valve with the design to close rapidly with the nozzle pressure exceeding 50 psi gauge setting of the pressure relief control that it reopens when the pressure drops below 50 psi gauge set point. Some type 3 systems use the towable pantographs instead of the hydrant hose trucks. The operating use the towable pantograph with the hydrant closed valve similar to the operation of hydrant hose trucks. Your hydrant control valve opener type 3 show the CRL check valve with the type air dead man 3-way hydro CRA fuel system venturi with the ComNet or NCN CV flow VPI flow king strainer outlet API adapter. Alright, 44281, inspection made with the hydrant control valve. For more information on the feature of the valve, statement with the replacement, refer to the commission document that is built with the manufacturer operation manual with the manuals. Refer to the hydrant control valve with the maintained 40 psi gauge nozzle with a pressure rate of 50 to 600 gallons per minute. Verify that the hydrant control valve closed with the normal nozzle pressure with exceed with 50 psi gauge. Verify with the hydrant quarterly. Verify the hydrant control valve opening speed is with a minimum of 20 seconds frequency quarterly. Verify that the hydrant closed valve opens, dead man control lever is pressed frequency quarterly. Verify the hydrant control valve is closed within 2 to 5 seconds after the dead man lever is released with the frequency quarterly. For section 4321, general system control valve for additional inspection, maintenance, and requirements. 4429, emergency shutoff valve. The valve has removed the standard type of 3 of the design and still exists within some systems. The new type of the 3 systems achieve the same function as the emergency shutoff valve, that include a similar function of the fuel separator control valve. Emergency shutoff valve that means the requirement of the Unified Guideline Spec 33, 52, 43, 14 aviation fuel control valve has 2 solenoids energized with the power is on, enabling the main valve of the opening with the fuel is flowing with the should power off fail. Should power fail when the emergency stop button be pushed, the solenoid is de-energized with the main valve is closed within 10 seconds with the valve opens. The thermal relief of the feature relieves excessive cover chamber with the pressure pack of the valve inlet with the differential control is to maintain relatively constant differential pressure between the inlet and outlet main valve. Emergency shot valve type 3 with a hydro ball check with solenoid A, hydro solenoid way 3-way valve with a common NTO differential control CBD CDB 7 outlet and inlet. Inspection maintenance emergency shutoff valve. For more information, feature the valve statement with the replacement, refer to the commission document that is built. Manufacturer operation maintenance manual with the ensure for the solenoids A and B the energized with the under normal operation frequency quarterly. Ensure solenoids A and B the de-energized emergency stop with the condition frequency quarterly. Test emergency stop function with the valve underflowing condition. Ensure the valve closed within 10 seconds of the EFSO button activation. Coordinate test over the EFSO. The test is listed in the section 9121 inspection maintenance electrical equipment frequency quarterly. Provide differential control meaning for the constant PSI gauge the differential pressure between the inlet and outlet valve with the frequency quarterly. Ensure the thermal relief of the ball check valve will relieve the excessive pressure for the cover for the chamber with the pressure exceed the inlet pressure frequency quarterly. Refer to section 4321 general system control valve with additional inspection maintenance requirements. Alright, 4-5, hydrant system type 4. The general description type 4 hydrant system is similar with the function with the type 3 system, except for the type 4 system is with a fixed band of gravity design, fixed wing, small frame aircraft. Direct fueling system type 4 system is often designed to support the hot refueling operation system, specific control valve, high level shutoff valve with refer to section 896 with the high level shutoff valve with the inspection maintenance requirement of the type 4 high level shutoff valve. Non-surge check valve refer to section 4421 for the non-surge check valve with the inspection maintenance for the non-surge check valve. Filter area separator control valve with refer to section 4422 for the filter separator control valve with the inspection maintenance requirement of type 4 filter separator control valve. Defuel flush valve with the refer to section 4423 for the defuel flush valve with the inspection maintenance requirement of type 4 defuel flush valve. Ignore maintenance for the inspection requirement of the type 4 valve with the system not equipped with the defuel flush valve. Flush valve with the refer to section 4423 for the defuel flush valve with the inspection maintenance requirement of type 4 flush valve. Ignore maintenance inspection requirement of type 4 system and the not equipped with the flush valve with the issue ventry with the section 4424 issue ventry with the inspection maintenance requirement of the issue ventry with return ventry with the 4425 with the return ventry inspection maintenance requirement of the return ventry. Back pressure control valve with section 4426 with the back pressure control valve with the inspection maintenance of the requirement of the back pressure control valve, the pressure control valve section 4427 with the pressure control valve inspection maintenance with the requirement of the pressure control valve, hydrant control valve 4428 hydrant control valve inspection maintenance requirement of type 4 hydrant control valve, emergency shutoff valve with the emergency shutoff valve with the inspection maintenance of the requirements of the ESO or emergency shutoff valve with the pantograph with the control valve with the pantograph with the control valve. Well, is you the control of the flow of the pressure for the flow through the pantograph of the unit of conduction with the pantograph of the entry, the install of the downstream with the pantograph of the control valve of the valve is equipped with the dead man control lever. 42512-1 inspection maintenance pantograph of the control valve of the pantograph. The pantograph of the control valve maintains 55 psi gauge nozzle pressure for the flow of the 50 to 600 gallons per equally quarterly. The pantograph of control valve will open with the dead man control lever is pressed frequency quarterly with G with the pantograph control valve with the maximum of 10 seconds with the after the dead man lever is pressed. Release frequency quarterly. Reverse section 4321 general system control valve with additional inspection maintenance with requirements. Pantograph of the pressure control valve. Pantograph of the pressure control valve with relief of the pressure for the pantograph downstream of the pantograph. The PTCV with the pressure pantograph control valve over the pantograph of the pressure control valve. The setting with a 70 psi gauge prevents excessive pressure from reaching the aircraft over the fuel tank. Alright, your inspection maintenance of the pantograph of the pressure control valve, the frequency pantograph of the pressure control valve that opens with a 75 PSI gauge, frequency quarterly, panographic pressure control valve, opening and closing speed with 3 seconds per second. 4-6. Hydrogen system Type 5. General description of the Type 5 hydrogen system similar with the Type 4 system except for the refueling points with the look of the hardened aircraft ship with the hydrogen system. General equivalent panograph with the meet with the requirement of U5 guidelines spec with the 33, 52, 43, 412 with the aviation fuel. Panograph with the aircraft fueling facility. The panograph that can be fixed with a single location mounted with a towable frame with the make with the mobile. The panograph that have the normal swivel joint focus of the panograph with the main of the center of the care of the joint of the panograph that have sufficient number of the swivel joint that prevent the excessive strain. Movable joints with the made for the periodic with the lubrication equipment. The lubricated swivel to replace the packing seal of the O-rings, the opening existing lubricated swivels showing signs of the leak of the failure should be replaced with the stainless steel non-lubricated type swivel. The care must be taken with the ensure the grounding of the binding of the wire to not damage during the maintenance allowed with the deteriorate the panograph retrieve with roughly during the refueling operation. Personnel will perform preventive maintenance that must be altered leaks, wet spots, erratic mechanical operation. Your fixed panographs are connected with to the piping single location or not relocated. Fixed inspection with the maintenance of fixed panographs. Placing tighter pantograph under static pump with the head pressure check for the leaks and this ease of the movement of the damaged grounding binding wire frequently monthly. B. Inspect the wheels if equipped with the warping check for the cracking of the uneven wear frequently quarterly. Inspect the exposed piping and connecting the corrosion frequently quarterly. Refer to section 473 for the fueling nozzle for the inspection maintenance of the requirements of fueling nozzles and show the fixed panographics. Are your mobile pantograph with the mobile pantograph with the location for the equipment with the fixed pantograph with the hydrant fuel hose tank with the pantograph with the mounted with the wheel that can be towed. Each pantograph with the equipment with the hydrant adapter, U with the connection for the hydrant control valve, the fuel nozzle, and U with the connection for the aircraft receiving fuel. 47121 inspection maintenance with the manual mobile pantograph with the pantograph with the yield of the stack pump with the head pressure for the check for the leak for the ease of moving the damaged ground bounding wire frequency monthly. They inspect the exposed pipe with the component with the corrosion frequency quarterly. Lubricate the wheels quarterly. Inspect wheels for warping, cracking, and uneven wear frequency quarterly. Refer to section 472 for the hydrant adapters. Inspection made with the requirements of the pantograph with the hydrant adapters. Refer to section 473 for the fuel nozzle with the inspection made with the requirements of fuel nozzling, hydrant adapters with the connection to the hydrant control valve with the hydrant adapters installed with the hydrant hose truck, mobile pantograph with the inspection made with the hydrant adapter, the proper operation of damage aware of the frequency quarterly, testing operation for the high brake of the system frequency quarterly, shift 40-23 for the hydrant adapter, 473 fuel nozzling, even connected with the issuing of the refueler truck for the aircraft with the air and issue for the fuel issue system pantograph with the R11 the refueler, R12 hydrant hose truck with the other system and issue for the fuel with the fuel nozzles equipped with a 600 wire mesh screen to trap particle with the issue system. 424 show the fuel nozzling. The inspection made the fuel nozzle with the inspect for the condition of the dust cap of the aircraft adapter and with ensure the good working order. Dust caps must be attached to the nozzles when they are not in use frequently monthly. Test leak of the resistant pop of the valve against the fuel pump thresher. Unusable condition found with during the test indicate that the repairs necessary for the nozzle must be removed with the serve the frequency monthly. Inspect for the storage rack with the moisture, dirt, accumulation correct condition for the may attributing the accumulation for the moisture and dirt with the store for the frequency monthly. Remove the nozzle inspection of the content impinged upon the mesh screen with the cleaning of the dry screen with the before the nozzle return the surface with the strain with the ball valve check with the install with the upstream with the nozzle only with the trainer ball valve needs to be checked. The nozzle should not be used with the trainers or remove the upstream with the ball valve with the frequency monthly. Test nozzles interlock with the entering the in-locks, prevent release of the fuel when the fuel nozzle is not properly connected. Adjusting the sleeve of the pop of the valve is required frequently monthly. Check with the operation manual valve with the cranking. Assembly smooth with the positive the motion with a special test standing frequency monthly. Alright, 474, surge suppressors. In a fluid of line of liquid of the pipeline suddenly stop with a high pressure valve can be created with a kinetic entry flow with a converter to the pressure for the resulting pressure spike with a kickoff of the leak of the damage connect with the equipment with the common device designed create the pressure spike for the pipeline with the surge suppressor can reduce the pressure for the spikes but will not eliminate them entirely. Surge suppressors can be constructed with a diaphragm or bladder surge with the compressors are equipped with the top mounted with pressure gauge with the isolation limited with the belly back check valve with the end made drains. 471. Inspection made with the surge suppressors. Inspect with the nitrogen leaks. Bladder pressure inside of the surge suppressor must be validated. Recharge with the need with the nitrogen surge suppressors. Also equipped with the need valve. Some established for the startup. The commissioning document should be maintained. Just nitrogen chart with the manufacturer recommendation quarterly. Show the valve guard the surge suppressor. Shows the bladder assembly stainless steel plug with a shell assembly gas plug backup ring O-ring extrusion ring, O-ring, pipe plug, pressure gauge, plate and gas nameplate, socket head, cap, screw, lock, run, gas valve, guard assembly. Alright, 4A, hydrant system product recovery. A system stores the flow from the drain line filter, separately drain with the thermal relief valve of the other component of the permanent flow of fuel for the separately of the water to drain off, and with the fuel return to the storage tank. Overfill valve of the product recovery tank with the overfill valve of the meat of the requirement of the Unified Guidelines Spec 33, 52, 43, 14, aviation control valve, installed with the on product recovery tank with the overfill with the valve due to the sap of the flow of the product of the recovery tank with the product recovery tanks every high level condition, high level alarm activated with the 85% of the full capacity, high level of the alarm activated 90% full capacity, and your overfill valve closes at 95% full capacity. The valve is equipped with a pressure relay valve with a supply with a hydraulic pressure where to operate the valve with a reservoir pressure supply with a fuel transfer pump with the install of the product recovery with a fuel transfer pump operated with the pressurized fuel is supplied with a reservoir utilized with the check valve with the isolate with the pressure and reserve automatic opening and closing of the overfill valve is controlled with the flow to the inside of the product recovery. The overfill valve is closed upon loose with the reservoir pressure. Alright, 4-2-26, overfill valve of the product, recover the pressure reservoir, check valve, wide strainer of the isolation valve, the limit switch of the pressure feed, reserve flow with the fitting, the remote manual flow tester, inlet and outlet with the pressure relief valve, and then flow control. 481, for inspection mainly the overfill valve of the product recovery. The form information feature of the valve setting with the replacement refer to the commission documentation as built in the manufacturer. Operation mainly with the manual. Verify the green light illuminated with the pump with the control panel. Graphic with the display with the overfill valve that is open in frequency semi-annually. Ensure the pressure reservoir bladder is charged 13 to 15 psi nitrogen from the reservoir. Hold the fuel pressure for the semi-annually. Verify the overfill valve closed with the control flow with the issue normally 95% full. For the arm of the manual tester is to lift the float with a note when the float is the product with the recovery tank the rise with the overfill closed with the pressure reservoir of the tank will decrease frequency semi-annually. Verify the red light is illuminated with the alarm and is activated with the pump of the control panel with the graphic display with the overfill valve is closed with the alarm is activated with the limited with the switch is installed with the overfill valve frequency semi-annually. Ensure the pressure reservoir of the tank hold with the fuel transfer pump, deadhead pressure of the flow transfer pump with the deadhead pressure with the pump is activated with the frequency semi-annually. Opening and cleaning the reservoir inlet strain frequency semi-annually. Refer to section 66 thermal pressure relief valve for the inspection made with the requirement of thermal and pressure relief valves. Alright, 482, product recovery the tank release detection. Underground double the wall product recovery the tank to provide with the release detection annual space for the inside-outside wall for the underground tanks. Product recovery tank release detection for the section 8, 9, and 13 release detection monitoring and inspection made with the requirements of the product recovery tank release detection system. 4A3, product recovery tank, automatic tank gauge. For the underground product recovery tank with the typically with the automatic tank gauge, they're similar with the underground storage tank with equipped with the automatic tank gauge. The 4A31 inspection made with the product recovery tank, automatic tank gauges. For section 898 for the automatic tank gauge for the inspection of the requirements of the product recovery tank, automatic tank gauges. 4A4 product recovery tank fuel pressure for the refer the recovery product recovery tank for the equipped with the transfer pump with the U for the transfer recovered fuel tank, fuel back to storage tanks for use. Inspection made with the product recovery fuel tank transfer pump refer to section 3813 vertical turbine submerged turbine pumps for inspection maintenance of the requirements of product recovery tank fuel transfer pumps. And this page is intentionally left blank, and we'll move on to chapter 5, marine receiving dispensing facilities.